Quantum computers utilize the principles of quantum mechanics to provide faster computational power than traditional computers. Today's computers represent data in bits, either zeros or ones, whereas quantum computers represent data in qubits. These qubits are in a state of superposition. Imagine a coin on its side being spun. When observed, you could say it is both heads and tails. This is similar to how superposition works within quantum computing. It allows us to calculate multiple paths at once. In addition, quantum computing also utilizes quantum entanglement. Quantum entanglement allows one qubit to change the state of one or many other qubits, allowing for us to calculate in parallel. But what are the impacts that quantum computing will have on traditional computers? Cryptography is the main area of discussion. Within cryptography, we utilize two types of encryption: symmetric encryption, which allows us to encrypt data with one key and decrypt it with the same key, or asymmetric encryption, which allows us to encrypt data with one key and decrypt it with the other. Asymmetric encryption is identified as quantum breakable. It would take a traditional computer 300 trillion years to break asymmetric encryption, whereas it would take a quantum computer with 10,000 qubits approximately 104 days. Symmetric encryption is seen as quantum safe and will be available to be used after quantum computers are fully out. It's also important to note that quantum is used within encryption today, and it is used for sharing and distributing keys. Quantum holds immense promise within the area of optimization and simulation. Think about carrier networks and how they can be optimized fastly using quantum, or supply chain optimization. These are just some of the problems it can solve for telecommunications. And machine learning. Quantum computing has the potential to parse very large datasets at once. Within telecommunications, this could mean we could optimize bandwidth usage and network usage in real time. It's important to note, though, that quantum computing has some problems. Qubits are extremely sensitive. That means if there is a change in electromagnetic waves or a change in temperature, they're prone to producing incorrect values. It is important for the future that we apply error correction to quantum computing for it to succeed.